All right, now we get into the word problems. So let's read this first one. Jennifer hit a golf ball from the ground into the air. Part A says, draw a picture of what you think the trajectory of would look like. Okay, of what you think the trajectory would look like. That was worded strangely. So if Jennifer's hitting the golf ball from the ground, I would guess that we're looking at the course of time here in seconds versus the height here, which I don't know, golf is maybe in yards or I would feet. I'm not quite sure. I'll just put height because it doesn't really tell us. So I would guess that when she hits the golf ball, she's probably starting here at ground level at time 0. So it looks something like this. Okay. Part B says it follows this path of quadratic where time is t in seconds and h is the height of the ball. Use our graphing calculator. So we're going to start over. Second plus 7, 1, 2. That way we all have a blank, clear slate to work from. We'll go to y equals. This is going to be our y. And this is kind of like f of x, where t is going to be our x. So we're going to put in y1, negative 16x squared plus 100x. And then we're going to hit graph. Well, that's not telling us exactly what we want it to tell us. First off, we need to think about what our domain restrictions are going to be, because it doesn't make sense for us to have any negative time. So if we go over here to window, and I change my x minimum, our x-axis, to just be 0, because I don't want to deal with negative time. I could do the same thing with my height and make my height 0. So now I just have the positive quadrants here. Still only a vertical line, but let's take a look here. Now we're starting to look a little bit more like this. I probably want to see a little bit more up higher, and this is where it gets really tricky, you guys, but it looks like she's probably hitting it more than 10, which we had originally guessed. So we want to increase our y values. So let's go to window, and we have our y maximum down here. Let's change this to 100 and see what we're looking like now. Oh, now we're starting to see a little bit more of a parabola, but not quite. So I'm going to change my window again, and this is the part that gets a little bit tedious, but you just have to play and keep trying until you get a nice parabola here. So I'll just, with this one, I can kind of grab it and bring it over here. Oops. So we'll put it right over the top, maybe, and erase that mark left. And I'll just label the x and y axis. This is my seconds and this is my height, and it looks kind of like what we did before. Let's see what questions they're asking us. So part C says, find the highest point that her golf ball reached. What key concept does this refer to? Well, the highest point, if I'm looking right here, this is going to be the highest point. So that's going to be my key concept of a vertex. So I'm going to be looking for my vertex. And because it's concave down, I'm going to be looking for a maximum. So I'm going to go to second, calculate. Maximum is number 4. Remember, we want to get over to where we think approximately it is. And then left bound, we want to hit, let's see, there, it looks like my vertex. So left bound, I go 1, 2, press enter. Back over to my vertex. Right bound, I go 1, 2, enter. And then my guess, I hit enter. So for a maximum, I got 3.12, 156.25. Now we have to understand what our vertex is telling us, because it's asking us for the highest, the point her golf ball reached, the highest point. Well, that is actually our y value. That was our height. So 156.25 in height. We don't know whether it's in meters or yards or feet. I'm guessing it's probably feet, but part D says also find when it hits the ground again. Which key concept does that refer to? Well, if I look at my projectile here, it's going from here to here. When it hits the ground again is this point right here. And that is going to be our 0. So let's find that. So if I go back to graph, if I'm going to hit that, so I want to go second, calculate, number 2. So remember, you want to move over to that 0. I can look right about here and hit enter. And then we'll hit right over for the right bound and hit enter and then guess. So now we have 6.25 comma 0. This is our x-intercept, and it happens at 6.25 seconds. So, if that was a little bit hard to see, if I change my y minimum to be -10, it might be easier for you to see that 0, and you can even go back to your window and say, no, I'm still not quite seeing it. Change it to be -100 and hit graph again, and that'll help you calculate the 0. So now it's asking us reasonable domain and range. Well, our domain, remember, is going to be all of our x values. So we want to think about, well, we already talked, it's going to be something right here, right? So our domain is going to go from when the smallest value x can be is 0, and then the largest x value happens right here at 6.25. And our range, if we look at our range, that's our y values here. So we can't go underground, so it's going to be 0 on our y values, and the highest that we go is our maximum, which is 1.5625.